In this video, we are going to represent algebraic expressions with area models of algebra tiles. So I have these algebra tiles that are making up kind of an irregular shape. And I want to be able to write a simplified expression for the area and for the perimeter. So let's start with area because that's probably the easiest. So I already have my y block, my xy block, and this x labeled here. So I'm going to finish off by filling in these two. So this one over here on this side is also a y. And this one here is an x. This one here is a 1. And this is a 1. So altogether, I can see that I have two x's. I have one xy. I have two y's. And then I have two 1s. So notice that I'm counting how many of each I have. Also take note that I started with x to y. Typically, when we're writing expressions, we like to do it alphabetically. So if x comes before y, that's why we have this transition. If it were A, B, and C, we would have A's first, B's, then C's. That's one of the ways we write it. So let's look at the more difficult one, which is finding perimeter. Because this is an irregular shape, it makes it a little tricky. So we have to think about what makes y the area. So that means this length here is a length of y, and this length here is a length of 1. Y times 1 gets me an area of y. So now we would go on to this one. Well, I know my length here is y. That means my width here is x to give us an area of xy. So I'm just going to label this one as I did over here because that's a y. The next one down here is an x. To get an area of x, that means I'm multiplying x by 1. So this is a length of x by a length of 1. So I'm going to kind of draw an arrow here because we're going to have multiple ones that we are going to have to deal with. And on the other side, you can see that it should be the exact same thing. So these are all 1s. Now when I go over here, I know that this side is a 1 and this side is a 1, since 1 times 1 gets us 1. This is also the same. So then we run into this one issue where how do I account for this? So we're going to get to that in a minute after I write down everything else. So the first thing I'm going to do is say that this side right here is x plus 2. So I have x plus 2 that defines this side. So over here, I'm going to write x plus 2. Now I'm going to work my way around and kind of bounce around. So I have a y here and a y here. So I have two lengths of y. And then when I get over here, I have 1, 2, 3 1s. And on the other side, I have 1, 2, 3 lengths of 1. So now I have to figure out how am I going to deal with this. So there's actually multiple ways we can deal with it or think about it. It just depends on your interpretation. So I would suggest pausing and taking a second for yourself to see how you would define it. Because the way I define it might not be the same way, and that's okay. So the way I would define it is I'm saying, well, this whole length is x, and that's including these two right here, right? So I can say plus x because that's this whole length here, and that's kind of part of this, right? But if I want to not count those two on the side, and I just want to look at these parts right here, this is x minus 2. So I'm calling this x minus 2 to represent this right here and this right here. So now I'm left with a 1 here, a 1 here, a 1 here, and a 1 here. So 1, 2, 3, 4. Again, there are multiple ways you can do this. Keep that in mind. So now I'm going to simplify my expression. I see that I have two x's, that I have two y's, and that I have 3 plus 3, which is 6, 6 plus 4, which is 10, and 10 minus 2, which makes it 8. So plus 8. So our perimeter is 2x plus 2y plus 8.